Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have e to the power x times x minus 1 the whole divided by 2x square. Right? So what we've been given is dy by dx and we've been asked to find y. And my y is nothing but integral of the given expression. So let's write down what our y is. So that's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. But can I do a little bit of jugglery with this particular expression so that I'm in a position to make my y a lot more simpler? And if you've not taken a look at my previous video where I discuss functions of the type e to the power x times f of x plus f dashed of x, then I'll put a link to that particular video in the description and I request all of you to take a look at that. Now, this is a problem of similar type. And why is that? You will understand when I do a little bit of rearrangement out here. So I'm going to rewrite my y in a slightly different way. I notice that I have a 1 by 2. So I pull out that 1 by 2 outside the integral. And then when I rewrite the expression inside the integral, I have an e to the power x, which I write it as it is. And then what I will have inside the bracket now is x minus 1, the whole divided by x square, right? And when I decompose that, what do I get? And I'll still retain it within the bracket. I will get an x by x square, which is nothing but a 1 by x, right? Minus of a 1 by x square. So now you see the y that I have post decomposition can be rewritten as half of integral of e to the power x times 1 by x minus 1 by x square times dx, right? Now are we in a position to make our y a lot more simpler? The answer is yes. And why is that? Because you are in a position to connect 1 by x with minus 1 by x square, right? What is the connect? D by dx of 1 by x is nothing but minus 1 by x square. And I expect all of you folks to know this from our lessons in differential calculus. So when I make the substitution t equals e to the power x divided by x, right? Or let me call it e to the power x times 1 by x, right? So now here my t is of the form uv, and therefore my dt by dx is nothing but udv plus vdu, right? Now what is my udv is nothing but e to the power x times my dv becomes minus 1 by x square, okay? My vdu is nothing but e to the power x into 1 by x. Why is that? Because my d by dx of e to the power x is e to the power x itself, right? So this is what I get. So this is my dt by dx. And if I do a little bit of rearrangement, I pull out my e to the power x because that's a common factor. And then what I get inside is nothing but a 1 by x minus 1 by x square, right? I hope you folks are with me. I pulled out e to the power x. So my dt by dx is equal to e to the power x times 1 by x minus 1 by x square, and therefore my dt equals e to the power x times 1 by x minus 1 by x square dx, right? Now in place of this expression, what I have, I can replace it with a dt, right? If I assume that my t is equal to e to the power x times 1 by x, right? And I know the answer for this, it's not very difficult. It is nothing but t by 2 plus my constant c, right? Now I need to express my answer in terms of x. Therefore, I go back and replace my t as e to the power x divided by x. And I'm left with my final answer, which is e to the power x by 2x plus c. So there we are. Yeah, I like my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.